All right, so we're going to look at these two problems. We'll do two videos. Part one of the video will be for the top problem. Part two will be for the bottom problem. They're very related. The setup on part one will help us for part two. Now, the truth is, you can just go right at this thing. You can use the fundamental theorem of calculus, and you can say that the derivative with respect to x of the integral from a to x of f of t dt is little f of x. And if you understand the fundamental theorem of calculus, that's easy. There's really no work to do. That's why the fundamental theorem is so powerful. But I'm going to view this, I'm going to show this to you in a bit more involved way. And you wouldn't really want to do what I'm going to show you on a problem this easy. But it's really going to help you on the second problem. So let's do it. All right, let's move that out of the way. Okay. So what I want to do is I want to start with just the integral. We'll take the derivative in a second. But let's look at the integral with respect to the integral from a to x of f of t dt. And let's use fundamental theorem, but let's use the other part, the other representation. And let's talk about big F. Big F being the antiderivative of little f. Well, the statement here would be it's big F of x minus big F of a. Okay? Again, you're comfortable with fundamental theorem, so that should be okay for you. Now, let's take the derivative of both sides. Let me make this a little smaller. Okay, now we're going to take the derivative with respect to x of the integral from a to x. And we're going to take the derivative with respect to x of the right side as well. Okay. Well, the thing on the left is what we're trying to find, so let's focus our energy to the stuff on the stuff to the right of the equal sign. Again, we're going to make this a little smaller. What we're trying to do, I'm going to make this really small, I hope that's okay. What we're trying to do is we're trying to show that, well, I'm sorry, I misspoke. I'm new to this whole thing. Thanks for your patience. I'm having so much fun doing this. Okay. Refocus. Okay, well, the derivative of big F is going to be big F prime. So I'm going to say then equals, I got to move this again. Oh, that's so cool. Okay, I'll move it over here. All right, so equals big F prime. Okay, that didn't work well, did it? Let's try that again. Big F prime of x minus big F prime of a, right? I mean, the derivative of big F is big F prime. Well, let's look at this f of a. A is a constant, so then f of a is a constant. What happens when you take the derivative of a constant? You're right, you get 0. So really that's just 0 right there. I don't want to write that anymore. It's just big 0. So we'll move some of this out of the way. Oh, it's attached to it. That's kind of cool. Okay. So what we have here then is just big F prime of x. Okay, well, using the fundamental theorem of calculus, by the way we defined this thing up in the first step, big F prime of x is little f of x. By definition. So I'm done. Now, again, that's way too much work to do, but we're going to use that same thinking on the next problem, and it's really going to pay off.